Welcome to Bedtime Astronomy. Explore the wonders of the cosmos with our soothing Bedtime Astronomy podcast. Each episode offers a gentle journey through the stars, planets, and beyond, perfect for unwinding after a long day. Let's travel through the mysteries of the universe as you drift off into a peaceful slumber under the night sky. A timeless allure, the enduring dream of time travel. The concept of time travel has transcended cultures and generations, weaving itself into the very foundation of human imagination. Since the dawn of storytelling, we've been enthralled by the notion of venturing into the past or future. This fascination isn't simply a whimsical fantasy. It stems from a deep-seated desire to understand our place in the grand narrative of time. Time travel offers the potential to revisit cherished moments, rectify past mistakes, or peer ahead into the unknown chapters of our existence. It allows us to contemplate the what-ifs of history, to ponder alternative choices and their potential consequences. The allure of time travel lies in its ability to bridge the gap between the present, the past, and the future, offering a glimpse into the vast possibilities that lie beyond our immediate experience. Beyond science fiction, unveiling the theoretical framework. While time travel remains firmly rooted in the realm of science fiction, theoretical frameworks have emerged that challenge our traditional understanding of time as a fixed entity. Einstein's theory of relativity revolutionized our perception of time, positing that it is relative to gravity and motion. Imagine a bowling ball placed on a trampoline, creating a depression. Similarly, massive objects like stars warp the fabric of space-time, influencing the flow of time in their vicinity. This warping of space-time offers a potential avenue for time travel under specific conditions. The theory of relativity, along with other emerging concepts like wormholes, hypothetical shortcuts through space-time, and closed time-like curves, loops in space-time allowing travel back in time, spark scientific inquiry into the possibility of manipulating the very fabric of reality. These theoretical frameworks, though unproven, provide a foundation for exploring the potential mechanisms of time travel, even if the actual realization remains a subject of ongoing scientific debate. A paradoxical path, navigating the challenges of time travel. The theoretical possibilities of time travel are undeniably intriguing, but they are not without significant challenges. One of the most prominent hurdles is the potential for paradoxes. A classic example is the grandfather paradox. If you travel back in time and prevent your grandfather from being born, how can you then exist to travel back in time in the first place? This paradox highlights the potential for creating inconsistencies and disruptions in the timeline. Imagine meticulously planning a trip back in time, only to arrive and discover your actions inadvertently erase your own future existence. The grandfather paradox exemplifies the cause and effect conundrum inherent in time travel. Theoretical safeguards. The Novikov self-consistency principle. several theoretical frameworks attempt to address the paradoxical nature of time travel. The Novikov self-consistency principle proposes that time travel, if possible, might adhere to a set of rules to prevent paradoxes. This principle suggests that time travelers cannot alter the past in a way that would create inconsistencies with their own existence. Imagine arriving in the past brimming with intentions to change history, only to find yourself unable to directly influence events that led to your own future. The Novikov principle proposes a form of self-preservation for the timeline, ensuring that a time traveler's actions cannot create inconsistencies that would negate their own existence. While the Novikov principle is a hypothetical concept, it offers a potential solution to the paradoxical nature of time travel, suggesting a set of safeguards that could maintain the integrity of the timeline. Time dilation and closed time-like curves. Exploring alternative travel mechanisms. Beyond the warping of spacetime by gravity, another avenue for time travel emerges from the theory of relativity: time dilation. This phenomenon posits that time runs slower for objects moving at incredibly high speeds or in the presence of strong gravity. Imagine a scenario where astronauts on a high-speed spaceship age at a slower rate compared to people on Earth. While not strictly time travel in the traditional sense of journeying to the past, this time dilation effect could allow for a one-way trip into the future. However, the limitations are significant. The velocities required to achieve a noticeable time dilation effect approach the speed of light, which is currently beyond our technological capabilities. Additionally, the traveler would arrive in a future that has significantly progressed compared to their point of departure, essentially skipping a vast swathe of history. Another intriguing concept is the closed time-like curve, CTC. This hypothetical construct proposes a loop in spacetime that allows for travel back in time, but inevitably leads the traveler back to the point where they initiated the time travel in the first place. Imagine a loop where your actions in the past are predetermined, essentially erasing any free will during your time travel experience. The concept of CTCs raises numerous questions about causality and the possibility of altering or being trapped within a predetermined loop of events. While the existence of CTCs remains purely theoretical, they offer a thought-provoking exploration of the potential cyclical nature of time travel. The many worlds interpretation and parallel universes. A different approach. The many worlds interpretation of quantum mechanics presents a unique perspective on time travel. This interpretation suggests that every possible outcome of an event creates a new universe. In this context, time travel could involve branching into a parallel universe where your actions create a new timeline without affecting the original one. Think of it as creating a copy of the timeline where you can explore different possibilities without altering the original course of history. For instance, imagine traveling back in time to prevent a historical tragedy. According to the many worlds interpretation, you wouldn't necessarily change the original timeline where the tragedy occurred. Instead, You would create a new branch where your intervention alters the course of events. While the many worlds interpretation is a highly debated concept within physics, it offers a potential solution to the paradoxes associated with time travel by suggesting the existence of independent timelines. The exploration of time travel theories delves into complex physics and philosophical questions. While the practical realization of time travel remains in the realm of science fiction, these theoretical frameworks continue to spark scientific inquiry and philosophical debate. The ethical labyrinth: navigating the moral implications of time travel. The ramifications of time travel extend far beyond the scientific realm and delve into a complex ethical labyrinth. The ability to alter the past or visit the future raises a multitude of questions that demand careful consideration. One of the most pressing concerns is the potential manipulation of history. Imagine a world where powerful entities could exploit time travel to rewrite historical events, potentially favoring specific outcomes or erasing inconvenient truths. The potential for misuse of time travel technology necessitates the establishment of robust ethical guidelines and international regulations. Beyond manipulation, the potential for unintended consequences is a significant ethical concern. Time travel could disrupt the delicate balance of historical events, inadvertently leading to catastrophic outcomes. Imagine a scenario where a seemingly minor change in the past creates a ripple effect that alters the course of history in unforeseen ways. The ethical responsibility of time travelers becomes paramount, requiring careful consideration of the potential ramifications of their actions before venturing into the past. Philosophical ponderings: time travel and the human condition. The exploration of time travel compels us to confront profound philosophical questions about the nature of free will, causality, and the very fabric of reality. One core question revolves around the concept of free will. If time travel allows us to revisit past events or witness predetermined futures, does it negate our ability to make free choices? Imagine a scenario where your actions in the present are predetermined by your knowledge of past events gleaned through time travel. This deterministic view of time travel challenges the notion of free will, suggesting that our choices are merely an illusion within a predetermined timeline. Another philosophical question concerns the concept of causality. Time travel introduces the possibility of altering past events, potentially creating paradoxes and disrupting the established cause and effect relationships. Imagine a scenario where a time traveler prevents a pivotal historical event from occurring. This action would ostensibly alter the course of history, potentially creating inconsistencies and raising questions about the true nature of causality. Exploring time travel forces us to reevaluate our understanding of cause and effect, and the potential for disrupting the delicate balance of events that led to the present. The ethical and philosophical implications of time travel are multifaceted and far-reaching. These considerations are crucial for guiding the development and potential application of time travel technology in the future. By acknowledging the ethical dilemmas and philosophical complexities, we can ensure that any potential exploration of time travel is conducted with responsibility and a deep understanding of its potential consequences. A technological hurdle: the immense challenges of time travel engineering. Despite the intriguing theoretical frameworks, the practical realization of time travel faces immense technological hurdles. Current physics lacks a unified theory that comprehensively explains gravity and quantum mechanics, both of which are crucial for manipulating spacetime as envisioned in time travel scenarios. Imagine trying to build a time machine without a complete understanding of the fundamental forces and structures governing the universe. Further complicating matters are the enormous energy requirements postulated for some time travel theories. Warping spacetime to a degree necessary for time travel likely demands energy densities far beyond our current capabilities. Think of attempting to move a mountain with a teaspoon. The sheer amount of energy required for some time travel concepts pushes the boundaries of what we can currently generate. Beyond the limitations of physics, technological advancements across various fields are essential for building a time machine, even a theoretical one. Advanced materials engineering is needed to withstand the potentially extreme conditions encountered during time travel. Sophisticated computer systems would be required to map spacetime distortions, calculate safe travel corridors, and manage the immense energy requirements. Additionally, the development of robust safety protocols would be paramount to protect time travelers from the potential dangers of venturing into the unknown. The future of time travel: a journey of exploration continues. While time travel remains firmly in the realm of science fiction, the exploration of its theoretical possibilities continues to inspire scientific inquiry and philosophical debate. As our understanding of physics and the universe evolves, the door may one day open to manipulating the fabric of spacetime in ways previously thought impossible. Even if the practical realization of time travel remains distant, the journey of exploration is valuable in itself. By delving into the complexities of time travel, we push the boundaries of human knowledge, challenge our assumptions about the nature of reality, and potentially pave the way for future scientific breakthroughs. The search for answers about time travel may not lead us to a physical time machine in the near future, but it compels us to ask profound questions about our place in the universe and the very nature of time itself.